Okay, this is the notes for points, lines, and planes. So I'm just going to go quickly through the definitions here and how to name each of these. Okay, so points are just locations. That's the key to that one. They're simply locations. They're spots. And we denote where the location is with a dot on a diagram. So the image or the diagram here, you'd have a dot indicating where the point is, and then the label for the point right next to it. So point A. Okay, and we just simply name that as A. So point A or just A. A point has no length or width or height, so it has no dimensions, right? It's just that location. All right, a line, it says, is a series of points that extends in two opposite directions. Okay, so to name a line, we can pick 2 points that are on it. So in this line, we have an infinite number of points on the line, but they show 2 of them, A and B, and they show where those located with the dots. So I can pick those 2 points and then put the line symbol over top. So it's hard to see a little bit, but this is actually little arrows. So that's the line symbol right over AB or BA. The other way to name it is we can look at the little lowercase letter in the corner. So T is not a point because there's not a dot showing where it is. It's the label for the line. So the other way we can name this line is line T with that little letter in the corner. Collinear, co means with, linear means line. So with the line, collinear are points on the same line. So in this example, A, B, and C are all collinear because they're on the same line. Okay, the next one is plane. So I want to add some points onto this plane. Okay, let's get 3. So I'm going to add points A, B, and C. A, B, and C. Okay, so a plane, it's like the Cartesian plane, the XY plane you used in algebra. You have the y-axis and the x-axis, right? So it's 2-dimensional, it's flat, and it extends forever along the x-axis and the y-axis. So to name a plane, you can use the little label in the corner. It's a capital letter in the corner. Or the other way you can do it is we can pick 3 points that are on the plane that are not all in the same line or on the same line, that are not all collinear. So for example, we could name this plane ABC because ABC are all in the plane and they're not all collinear. They're not all on the same line. Okay, and then if collinear meant on the same line, coplanar is going to be on the same plane. So in our example here, we need to add a point D. So it says A, B, C, and D are coplanar. That's because they're all in the same plane. It also says line AB and line CB are coplanar because those lines are in the plane. So they're together in the plane. So collinear on the same line, coplanar on the same plane. All right, segments and rays. Segments and rays are parts of lines. Okay, they just don't extend forever in 2 directions. So a segment just ends at the endpoints. So A and B are the endpoints, and all the points in between are part of that segment, but they don't extend forever. It's just this part of the line, the red part of the line. To name it, we put the 2 endpoints, and then we just put a bar over top. No arrows, just a bar. For a ray, we go forever in one direction. So we have one endpoint, and then we go through another point, right, forever in one direction. To name it, we always put the arrow to the right. Always. The direction of the ray in the diagram has nothing to do with the name. Okay, so we always want to go arrow to the right. We want to put the endpoint first. In this case, the endpoint is y, and then we can put x. Okay, opposite rays are rays that go in opposite. They share an endpoint, and they go in opposite directions. So for this one down here, we want to look for a line with 3 points, like this one. We want to use the middle point as our endpoint. So we would do RS. Ray RS is opposite ray RQ. Right? RS and RQ. They're two rays that share the same endpoint, in this case R, and they go in opposite directions. They form a full line. All right, so let's look at some questions. So example 1 here. Okay, give 2 other names for line LN. So line LN is this one. Okay, we can name it with the little letter B in the corner. B is not a point on the line. It's just a little label in the corner, so we can call it line B. Okay, the other way is you can pick 2 points that are on the line. So L, M, and N, we just want to pick 2 of them. I'm going to pick M and N. And then we can put the line symbol over top. Okay, we could have done NM, we could have done NL, line NL, we could have done line ML or line LM. All of those would be good as long as you're putting the line symbol on top. All right, the plane. So let's look at the points. We need to know which points are in the plane. Okay, so the points in our plane are going to be L, M, N, and P. B is not a point. It's the name of this line. Z is not a point. There's no dot next to it. It's the label for the plane. Point Q is above the plane. And then A down here is the label for this line that's going through the plane. So these 4, L, M, N, and P, are the 4 points that are on the plane that they show. So to name it, we need to pick 3 that are not all on the same plane.
Huda Ahmed, contact the main office. Huda Ahmed.
Okay, so I'm picking 3 points. The ones I can't choose are L, M, and N because they're all on the same line. So I could do L, M, and P in any order. I could do L, N, and P or M, N, and P in any order. I'm going to do L, M, P. Okay, B here is name 3 points that are collinear. So 3 points that are on the same line would be L, M, and N. Name 4 points that are coplanar. So the 4 points on plane Z are L, M, N, and P. Okay. On the next diagram, when 2 lines intersect, they sometimes don't put the dot there showing what that point is. But in this case, it's W. Okay. So another name for segment VX, that's this segment right here, VX. The only other name I could give for that would be XV. Right? Segment VX and segment XV are the same. Whether you're going from X to V or V to X, it's the same segment. Okay, all the rays with endpoint W. So for starting at W, we can go WX. We can go WY. We can go WV. And we can go WZ. So green. So those are the 4 rays in the diagram that start with an endpoint of W. Again, notice how the rays all go in different directions, but when we name them, the symbol is always to the right. All right, which of these rays are opposite rays? So the blue and the green are opposite, and the purple and the red are opposite. So WX and WV. Okay, and then WY and WZ are opposite rays. All right, example number 3. We're going to sketch, do some sketches here. So I'm going to draw some planes for each of these. Oops. Oops. Perfect. Okay, the first one, sketch a plane and a line that is in the plane. So I want to draw this line entirely in the plane. So it's going to look something like this. It's inside of the plane. We're going to sketch a plane and a line that does not intersect the plane. So if it either needs to be parallel above the plane or it needs to be parallel below the plane. I'm going to draw mine below. Okay, C, sketch a plane and a line that intersects the plane at one point. So this is the point it's going to intersect at. It's going to go through the plane, up, and then down below the plane like this. So it's going up through the plane. I put the dashed lines to indicate where you can't see the line because it's below the plane. And then D, sketch 2 different lines that intersect the plane at the same point. So let's say they intersect here. I'm going to draw one going up this way. Then it goes down through the plane. And I'm going to draw another one up here. And again, it's going to go down through the plane this way. And there would be 2 lines intersecting the plane at one point, the same point. All right, example 4. We're going to sketch 2 planes that intersect in a line. So the way we're going to do this, I'm going to draw a rectangle that is taller than it is wide. I'm going to put 2 dots on the left and the right here. And then I'm going to draw a slanted line through both of those dots. And then I'm going to connect those slanted lines. And now I have 2 planes that are intersecting. And they're intersecting along this line right here. Okay. The diagram for example 5 is better than my drawing because it's computer generated. So obviously it's going to be better than mine. But that's fine. That's a good enough drawing. All right. All right. Name the intersection of line MX. So here's line MX. And line A. So where these two intersect is right here, which is point M. Okay, intersection of plane C, so that's the whole plane, with plane D. So 2 planes are going to intersect along this entire line in the middle here, and we call that line A. There's a little label here for line A. Imagine the room you're in where the floor and the wall meet. Imagine one wall is a plane, the floor is a plane. They're going to meet all along the entire seam where the floor and the wall meet. That's a whole line, not just a point. Okay, and then the last one. Intersection of line A, which is right here, and plane D. So line A is in plane D, right? It's entirely inside of plane D. So the intersection is the entire line itself, line A. The whole thing is in plane D, so all of line A intersects the plane. Let's move on to the next page. So we're going to name these. So the first one's a ray. So I'm going to put the end point first, and then the other point, Y. And then the arrow always goes to the right. Next one is a segment. So I'm going to put my 2 endpoints, and then I'm going to put a bar over top. These are points. So we're going to call them S. And we'll call the other one T, S and T. The next 2 are lines. So I'm going to put the 2 letters. It doesn't matter what order I put them in. WX or WY. I'm sorry, WX or XW. We just need to have the line symbol over top. and then CD, and we're good here. Okay, LM, right? We could start with the endpoint and then put M, and the arrow is going to the right. When we name array, the arrow always goes to the right in the name. You put the endpoint first and then the other point. The direction the ray is facing in the diagram has nothing to do with how you should name it. You put the endpoint, the other point, and the arrow is always facing right. Okay, these we're going to draw. So we have AB is a line. We know it's a line because of the line symbol. And we're going to put points A and B on the line. And there we go. C and D, to signify where a point is, we need to put a dot. So I have point C and D. RS is a segment. That's the segment symbol. So I need to have two endpoints, R and S. We're going to have points for L, M, and N. We got to put the dots signifying where the points are. 5 is a ray. So I'm going to have an endpoint M. It's going to go through point N forever. And then the last one is like the first one, it's a line. So I'm going to put J and K on my line. Right, 7 through 10 here, we're using this diagram. It got cut off. This should be an arrow right here. Right. So the first one is name the 4 points. So really there's an infinite number of points here. They don't show them all. They only show 4 of them. So we're going to put the 4 that they showed. L, M, N, and O. We're putting commas here because we're making a list. We're listing off the points. We're not, you don't want to put L, M, and O all together, smushed together. They're points that we're listing. If I told you to list the colors, you wouldn't write red, blue, green as one big word. You would put red, comma, blue, comma, green. So we're separating it, we're listing. 2 segments, 2 line segments. So we could do LN would be 1. We just need to make sure we put the bar over top. We could also do OM. That was a little off. OM, that would be another one. Right? You could do MN, or we could do LN. You just need 2 of them though. Okay, 3 rays. So we could do MN, ray MN. We could do ray MO. Or we could do ray ML. Okay. You could also do LN and NL. That would work too. But sticking with M is the main one there. Okay, and then our line, we're going to name this line in 3 ways. To name the line, we got to pick 2 letters and put the line symbol on top. So we could do LM. We could do MN. Or we could do LN. Okay, you could also switch those letters. So you could do L, NM, or NL, as long as you got the line symbol on top. All right, next one's the same questions, just a little bit of a different diagram. So the points we have here are R, S, T, U, and V. Line segments, you could have segment RS, you could have ST, you could have RT, you could have SU, you could have SV. And again, you could name them all the other way too. SR is the same as RS. Segment RS is the same as segment SR. Segment ST is the same as segment TS, and so on. Okay, the rays that we see here are ST, SR, SU, and SV. Okay, and then 3 ways to name the line. You just pick any of the two letters and put the line symbol on top. So we could do RS. We could do ST. We could do RT. You could also switch those letters. So SR, TS, TR. There are all three ways to name that same line. All right, last page, we got 3 diagrams with some questions. So the intersection of line QZ and segment WU. So here's segment WU. Here's line QZ. They intersect at point T. The intersection of plane pi and line DB. So if we notice line DB here, it's dashed and then it becomes solid. That's because it's not in the plane, it's going through the plane. So point B is below the plane. The line's coming up. It hits the plane at point S. And then D is above. It goes above the plane and through. So the place where it intersects is point S. Two opposite rays at point T, that would be TQ and TZ. Okay. And another name for plane pi, right? So the points in plane pi are these: W, Q, T, Z, and U, and S. D is above the plane and B is below the plane. So we can't use those because they're not in the plane. And then the one condition is, besides being in the plane, is that they can't all be on the same line. So I can't use Q, T, and Z together, and I can't use W, T, and U together. So I could do plane WQT would work. TUS, TZS, all of those would work. You just can't use W, T, and U together or Q, T, and Z together because they're on the same line. All right, the intersection of plane pi and plane tau. So this is the Greek letter tau. If you want to just call it T, that's fine, plane T. They're going to intersect right here. Okay, one thing in the diagram they don't really have, they didn't put dots for, this should be S and this should be B. But again, because they're intersecting, they feel that they don't need to put the dot in there. But it is nice to have the dot, it makes it easier to see. So those planes intersect at a line, right? Again, think of your room that you're in, the floor and the wall. They don't just meet at one point, they meet all along that seam. So it's a line. So this would be BS is how we would name this line, or SB. Or C, you could name it CS or SC or CB or BC. Okay, another name for plane pi. So let's look at the points in plane pi. You have G, you have C, you have B, you have S, L, and M. We need to pick 3 of them that are not on the same line. So I can't use M, C, and G together, and I can't use S, C, and B together. So let's see what I could do. I could do M, L, and C. M, L, and C. Okay. Can't use S, C, and B together, and I can't use M, C, and G together because they're on the same line. 3 points in the plane that are not on the same line. Okay, name the intersection of line BS and line MG. That would be point C. And a point that is collinear with M and C would be point G. Last diagram here. So we have the line LC, which is this line. It's going down through both planes. So on plane tau or plane T, it's going to intersect at L. It goes down between the planes, and then it intersects plane pi at C. So the intersection of the line in plane pi is C. The intersection of plane tau and LC is going to be L. Or again, plane T. This is really the Greek letter tau, not a T, but either way, it doesn't matter. Okay, a point that is coplanar with H and L would be P, right? H and L are in plane tau. We could also do P though. And then the opposite ray of CB would be CJ, ray CJ. The last two questions on here are drawings. So let's go ahead and make our sketches. Okay, so I have a plane. I'm going to do a plane. All right. ABS. So that means points A, B, and S are in here. So I'm going to do point A, B, and S. I might have to change where these go though, depending on what we have. Okay, we have lines A, B, C, D, and AK. And then it says line AB and CD intersect at point G. So I need a D in here. So I'm going to put D right here. Actually, yeah, I'm going to label D right here. Okay, so I'm going to draw in line AD. I'm sorry, it's AB and CD. So I also need a point C. So here's line AB. Let's draw better lines. AB, perfect. Okay, and I'm also going to put a point C right here. And I'm going to draw a line CD in the plane as well. So line AB and CD are going to intersect at point G. So there's point G right there. CD and AK intersect CD. Okay, so I'm going to have to move X or S right here. So I have AK. So I need a point K. I'm going to do a point K over here maybe. Okay, so line AK intersects at point S. So I have to move point S over here. And then line AB and AK intersect at point A. So that works. So let's check this. I have line AB. I have line CD. I have line AK. Check. AB and CD intersect at point G. Check. Line CD and AK intersect at point S. That's a check. And then line AB and AK intersect at A. They have to. That's a check. So that one's good. Next one, we're going to have two planes, pi and tau, or T again. You want to use T, that's fine. So let's try and draw them. So I'm going to draw my big rectangle, taller than it is wide. I'm going to put dots halfway between. I'm going to draw slanted lines. And then I'm going to connect those slanted lines. I'm going to call this one pi. And we'll call this one tau. Pi and tau. All right, let's see what we got here. Pi contains the line AB at point L. Tau contains the line EF at point S. Lines AB and EF intersect at point H. Okay, so I know, let's see. All right, I know H is going to have to be right here in the middle. So I'm going to have a line coming down. I'm going to have a line going this way. And they're going to meet at H. So this one is going to be in pi. I'm going to have AB. And then this one's going to be E and F. Okay. The intersection of plane pi and plane tau is LU. So I also need to put in, I'm going to put in a line here. And I'm going to put in point L. And I'm going to put in point U. So let's see. Plane pi contains the line AB and point L. So L is in both planes. So that one's good. Plane tau contains the line EF and point H. And H is right there in the middle. It's in both planes. So that one's good. Oh, I'm sorry, and point S. So I also need to put an S in here. Here, we'll put S right here. Now that one's good. Line AB and EF intersect at point H. The intersection of plane pi and plane tau is line LU. That one's good as well. So there's our diagram. It looks like it's good.